All right, so what we're going to do tonight is we're just going to do more of those simplifying problems. And what I'm going to give you guys right now are what we like to call tricks to try. So if you're trying to figure out where do I start, how do I look at this problem and know what to do? There's multiple ways that you can do any of these. So I'm going to go through about 7 things that you can try that could help you get a start. And then just know that if you start one way and it's not working out, maybe go back and try a different trick or start a different way so that you can get a simplified answer. So our first trick to try is to change everything to sine x and cosine x. So in other words, turn your tangents into sine over cosine, your secants into 1 over cosine. Try to get everything to be the same sine cosine functions. That's really helpful because it'll help you see things that might cancel or that you have a common denominator and you can add them together. So that's why sometimes sine and cosines are really nice to get everything into. Our second trick to try is to use a Pythagorean identity. So look at your problem that you're about to try to simplify. See if you have any of your Pythagorean identities in that problem or some manipulation of it. So let's say it was cosine squared x 1 minus cosine squared x. Well, that's just a manipulation of sine squared plus cosine squared equals 1. So look for those kind of things where you might be able to substitute in a Pythagorean identity to make it more simple. Our third one is to distribute or FOIL. So this is one that you might want to try if you have 2 trig identities being multiplied, or if you have a monomial trig, so one trig function being multiplied to a sum or difference, is to distribute, let's remember the E, or to FOIL, to start there maybe, see what that does. Our fourth trick is to try factoring, do the opposite of distribute. So if you see that you have like a sine squared, a sine, and then a number, try factoring. Or even if you had sine squared and sine, take out a GCF, see what that does. So try factoring out trig functions to see if that helps you get a start on simplifying. Our fifth one, get a common denominator. So this one's really good for when you're adding or subtracting. Getting a common denominator so that you can combine your fractions into one can sometimes get you started with simplifying. Our sixth trick to try to get you started would be to clear away complex fractions. So if you have like a sine x over cosine x plus 1 all over another fraction of trig functions, this would be one where you might want to start. How you get rid of those complex fractions is the same way we did it back in chapter 2 or chapter 1 or unit 1, unit 2. So we'll get rid of them the same way. And lastly, multiply by the conjugate. Okay, so when we multiply by the conjugate, a lot of times what that does, so if I had, let's say, a 1 minus sine x, If I were to multiply and again, remember, we have to do this with everything in the equation. If we multiplied everything by the conjugate, which remember is the same thing but with the opposite sign, when you FOIL this together, you get 1 minus sine squared x. Well, what is that? That's a Pythagorean identity. So sometimes when we multiply by conjugates, you can end up getting a Pythagorean identity that'll help you simplify further. Okay, so this is just some things that you can try to get you started, or when you get stuck, that you can look to do. There is no list to go through. There's no one way to go about this. You can jump around this list of 7 however you want to see what works. And sometimes you'll have a problem where only 1 or 2 of these things might get you started. Other times there might be 3 or 4 of them that could get you started. So it's just about using these as a way to start, and then you'll kind of start to see patterns and problems, how to actually do some. So what I want to do now is to just go through 1, 2, 3 here with you tonight, and then we'll do a couple more tomorrow, where we just use this list to help us simplify some trig identities or trig functions. So all of these are simplify. And so remember, to simplify just means we're trying to get it down to as few trig functions as possible in our answer. So we want to get it to the point where it's hopefully 1 trig function, like sine, cosine, secant, cosecant, tangent, cotangent. But if we get it to like sine times cosine, you can't really go anywhere else, so that would be our simplest form. So again, the goal is to get it into as few trig functions as possible. Okay, so the first one I wanted to do with you guys is secant theta minus sine theta times tangent theta. So when we look at this problem, I see a couple things that we could try from our list of tricks to try. One of the first things that I noticed that we can try is to change things to sine and cosine. So secant, I can turn that into 1 over cosine. Sine is already a sine, but tangent, I can change that to sine over cosine. So from there, I can simplify, I can multiply these together. So this is over 1. So I have 1 over cosine theta minus sine times sine is sine squared over cosine. I have a common denominator. That means I can add the numerators. From here, I see a Pythagorean identity. Right up here, if I were to take sine squared theta plus cosine squared theta equals 1 and move the sine over, I'll get 1 minus sine squared theta. So that means this whole top part can be rewritten as cosine squared theta. So that was using a Pythagorean identity. So now I have cosine squared theta over cosine theta. Now what I notice is that I can just reduce this. Remember, this means I have 2 cosine thetas on top and I have 1 on the bottom. That means I can cancel this cosine theta with 1 of them on top, giving me an answer of just cosine theta. So just to recap, on this one we started off by changing everything to sine and cosine, so we used the first trick to try. And then after we did that, we saw we had a common denominator, so we added the 2 fractions together, which then showed us that we had a Pythagorean identity in a different form. So we did that substitution and then reduced. Okay, the next one that I wanted to try with you guys tonight is secant squared theta minus 1 over secant squared theta. So on this one, we can look to see, do we have a Pythagorean identity? Or do you see something that you can rewrite as sine and cosine? We have all these different things we can think about. So if we look into our Pythagorean identities, and the only reason I'm looking at Pythagorean identity right now is because of this secant squared. So secant squared minus 1, this is one of our trig identities, or our Pythagorean identities. So that means I can rewrite this as tangent squared theta. And then on the bottom, I'm still going to have secant squared theta. Now from here, I'm gonna go and let's see, what can we try? We can't really factor, we don't have anything to multiply, we don't have anything being added or subtracted anymore, we don't have complex. Okay, I'm just gonna try doing everything to sine and cosine. So I'm gonna have sine squared theta over cosine squared theta. That's my tangent. And I'm going to take this division and I'm going to write it horizontally. Because secant is 1 over cosine squared theta. So I just took secant squared, turned it into a horizontal division, and rewrote it as its reciprocal identity, 1 over cosine squared. So next I'm going to turn this into a multiplication problem. So sine squared over cosine squared times cosine squared theta over 1. Using what we know about algebra, we can cross cancel because they're exactly the same, which means we would have sine squared theta over 1 or just sine squared theta. We have it down to one trig function. Okay, number 3, I'm going to have to flip the page. Our third one sine theta cosine theta times tangent theta plus cotangent theta. So again, with this one, I'm going to look at my list and try to think, what might I try? So I can start by distributing, because I do have something on the outside being multiplied to something being added on the inside. So if I look at that and multiply, I'm going to have sine theta cosine theta times tangent theta. So that's me distributing all of this to the first term, plus, and now I'm going to distribute all of that sine cosine to the second term. Sine theta cosine theta cotangent theta. From here, I'm going to go ahead and turn my tangent and cotangent into sine and cosine. So I'm still going to have sine theta cosine theta, and this is going to become sine theta over cosine theta. And all of this is being multiplied. Plus, and then we have sine theta cosine theta And cotangent will be cosine theta over sine theta. So I've converted, so we distributed and then changed everything to sine and cosine. Now when I look at this, I can think of sine cosine over 1, so that I can cross cancel my cosines in the first term, and I'm left with sine squared theta. Over here I can cancel the sine, and I'm left with cosine squared theta. Well, what's sine squared theta plus cosine squared theta? It's one of our Pythagorean identities. It's just 1. So there we would simplify down to 1. And that's as simple as that one can get. So tomorrow in class, we're going to do 2 more. And the 2 that we're going to do are going to use some of the other tricks to try. We're going to use some complex fractions. We're going to do one like that. And I don't think we're going to do a conjugate one, but I can try to find one. So hopefully this gives you at least an idea of some starting off points when you're going through your assignment of how to get going. Now, had we tried something different and it didn't work out, we would have to just start over again. And that's okay. It's okay to have to start over. At least you tried something.